In this exemplary circuit, we'll study a problem of identification of a circuit input excitation, namely this voltage source. For the given output, a circuit response power dissipated on a resistance, namely this resistance. So our problem in a block diagram, we have one input, we have one output, and our task is to find the value of this input for the given output, for the given power which is dissipated on this resistor. So at first we have to express this power by a resistor voltage or current. Let me assume that we will express by a resistor current, then current is a function of power. And as you can see, this current can be either plus or minus 0.1 amp. Next we have to formulate the circuit equations, and then we will take into account that this current is 0.1 plus or minus. Then nodal equations are presented here. I'm not going to discuss how these nodal equations are created. From these nodal equations we may find this voltage V, and then current, our current that flows through a resistor of R, and this is the current. Then after transformation of this equation we will find that the voltage input that we are looking for can be either plus or minus 40 volt. Please observe that first of all we have two solutions, and then these solutions differ only in sign. Why? Because we have only one excitation and power is a parabola. It is a mirror symmetrical curve like we can see here. So for that reason we have two values, but they differ only in sign. We have only one input, one excitation. Now let me continue. This is verification of our solution. At first it is PSpice analysis DC sweep. Let me assume that we start this voltage from minus 50 up to 50 volt, then trace is power dissipated on this resistor, and this is the trace. In this probe window we can read these two values are obviously plus minus 40. Now let me continue with nearly the same example. The difference is only that we have a second source here. Still we have same power dissipated on this resistor, and our task is to find the value of this source, but we have another source here. So our circuit has two inputs and one output which is given. Second input is given as well. We are looking for this value. So same as before, we have to express this current by power which is given. Then we have to add nodal equations to express this voltage by circuit parameters. Then current that we are looking for. Please observe this current now is sum of two components. First component is designated by our voltage source. The second component is designated by this source which is given. Then if we set that this current is plus minus 0.1 amp, we obtain that our voltage can be either plus 20 or minus 60 volt. So now we have also two solutions, but they differ not only in sign, they differ also in value. Why it is like that? Because we have two excitations, and power now is a quadratic function. Is a quadratic function, a function described by a quadratic polynomial which is not mirror symmetrical curve. Parabola that we have had before is a mirror symmetrical curve. Now we don't have such a curve, and obviously for that reason we have two solutions, but they differ in sign. So this is a task when we are looking for excitation for the given power dissipated on one of the resistors. Now, well, this is a verification by means of PSpice. I have changed these start and stop values in DC Sweep such that we have minus 100 and plus 100, and our solution confirmed minus 60 and plus 20. Now, same circuit, but a different task. Now we know that this source should absorb 10 watt of power, and the task is the same as before, to find this voltage. So we have the same block diagram as before. Two inputs, one output, but this output now is not power dissipated by a resistor, it is power which is absorbed by a voltage source, another input, which is given at 20 volt. So we should start first of all by applying a passive sign convention. As this power is absorbed, then for the applied passive sign convention we may calculate this current, and this is only one value, 0.5 amp. There are nodal equations below. Once again, I'm not going to discuss how they are created. Then from these equations we may find a current in this branch, a current that we are looking for. And obviously now this current, same as before, is the sum of two components. However, if we set this current to this formula, we obtain, and when we rearrange this equation, we obtain a voltage which is sum of two components as before, but it is only one value, only one solution, as a voltage source current, this current that designates our power, and this relationship is given here, is a linear function of excitation. Then also power is a linear function of excitation, power which is absorbed or supplied by a voltage source. The same can be repeated with the current source. Current source voltage also is a linear function of excitation, and also power supplied or dissipated by a current source is a linear function of the source value. Now verification by means of PSpice. In PSpice we have circuit diagram, repeat calculations. Now DC Sweep, we have to change start and stop value to minus 500 and 500, and this is a linear function. Our trace, obviously, it is power which is absorbed by this source, a product of this voltage and current. And please observe that for voltages of this source that are less than 60 volt, this second source, E sub 1, supplies power. We have a passive sign convention applied, and power is negative. For values greater than 60 volt, power is positive, which means that this source absorbs power, as we have a passive sign convention and power greater than 0. For this particular value of this voltage source, for 60 volt, this second source neither absorbs or supplies power. Okay, that way we have completed this exemplary problem.